Hello everyone, my name is Steven Figueroa and I'm in Dr. Alex Pons' EEL 4734 Embedded Operating Systems class at Florida International University, FIU. If you're watching this video, it also means you're in Dr. Pons' class, and like me, you also have to do a video project. If you're not in Dr. Pons' class, then I hope this video is informative for anyone that is watching. Today, I'm going to be talking about shell functions versus macros. What's a shell function? A shell function is basically known as little programs within programs, and they follow a top-to-down design procedure. This basically means that when you're executing a script, they execute all the way from the very top, all the way down to the bottom. Now, a couple of important things that we do need to remember about shell functions is that they must appear before you attempt to use them. Naturally, if they don't appear, then we can't use them whatsoever. But if we do use them, they have to be there before you run and execute a script. Another important thing that we do need to remember is that within the function body, which is basically between the two brackets, there has to be at least one valid command. If there is no valid command or it's completely empty, then we're going to have a bunch of errors and we're going to have a huge splitting headache trying to figure out what we want to do inside that function. One way to avoid this is to use the return statement inside the function body. This will avoid any errors inside our code, and it will execute and run smoothly like any other code. Now, when developing a program, it's good practice to first write a little bit of code, run the script, and if it works successful, then we add just a little bit more, and then we run it again. We keep repeating this process until at least we have a working, successful code size. This way, we can also use to identify any mistakes that we might have used during the process of making a code, and will also help us find and debug any problems that we might find later on while we're trying to execute a program. Now, one technique that's very useful is called stubbing. What's stubbing? Stubbing basically works like this. If you have a function that you don't know what you want to put in yet, but you know you're going to eventually add some things, we put in a temporary code until we figure out what we want to do with it. One way we can use a temporary code is with the echo command. The reason why we would use the echo command is because the echo command will give us some feedback as the script is running and will tell us which function is being executed at that time. It will tell us the first function that's executing, then the second, and then the next. That way we can identify what we want to put in the first function. If we want to put in a little something more or take something out, we do that. It runs the script, and then as it goes into the second function, we can figure out what we want to add into the following function, or if we want to take something out. To show you an example of how we would use the echo command in a stubbing function, here's how the code would look like basically. This is an example I borrowed from linuxcommand.org. As we can see in system info, they're using the echo command as a temporary function stub. This basically means that we don't know what we want to put inside the system info, but we still want it to tell us when it's being executed. And when it's being executed, it'll tell us when it's being executed, so we can see how long it'll be and then when the next function is going to execute. As we can also see in the following steps in drive space and show uptime, they each have a similar echo command, and this is also for the same reason as system info. It'll tell us when it's being executed until we figure out what we want to add inside each of these functions later on. If you're interested in seeing the full code of this example, you can always go to Google and type in the linuxcommand.org website, and you'll see the full command that's being used along with several other examples of stubbing. Now, another thing that we do need to remember about shell functions as well is that functions do need to be compiled. Once they're compiled, then of course they can easily run and they'll be executed, assuming that there is no errors whatsoever. Since they do need to be compiled, we do need to be careful as to what we type. If we type an error, or if the function is in fact case sensitive, then of course we're going to have a bunch of errors, and this could cause a great deal of headaches and frustration, just like every other programmers have to suffer from time to time. Now, the length of a code can be the same if a person wants, or they can add or remove depending on how big or small the programmer wants the code to be. This also helps us avoid any types of side effects, meaning that if we want to add something into the program, that there won't be any problems whatsoever, there won't be any hiccups along the way, but we do need to compile it once again in order to execute the new stuff that we've added. Sadly, this also slows down the speed execution. Since it slows down the speed, it could cause a bit of problems if we want the function to be time sensitive. Now, during a function call, there is a transfer of control that does take place, meaning that the code does surrender control as it passes along through the code. This is quite useful actually for larger codes, and it has appeared many times during these types of functions. And also, functions can have any number of lines. However, there is sometimes a bit of compile errors, like I've said, so we do need to be careful with functions from time to time. So now that we know a bit about shell functions, what is a macro? Well, a macro is basically a recording of a series of tasks that could save us hundreds of hours of codes that are being executed, and could be used repeatedly as many times as we want to basically do the same thing, like the setup macro. The setup macro is basically seen as a registration function, not like a shell function, quite different. It's a function that we use to register something, like the kernel that we're going to use in Ubuntu. Now, the setup macro is a bit complicated when you see it, and it does require a bit of linker help, but it is used basically when we have an unknown number of console functions that the user wants to use, but we don't know how many console functions we want to add. The basic objective of the setup macro is to build a static list of strings that are associated with function pointers. This list is then emitted into an ELF image and is then separated by the compiler into a final VM Linux ELF image as it compiles. It's very important when it comes to understanding the setup macro, since it's used in several places inside the kernel in order to execute the user's parameters that he or she wants to use. Now, the setup macro can be found in a file called /kernel/printkey.c. This is the console initialization routine called console_setup parentheses, and the kernel, this is basically the kernel command line parameters string as its only argument. The challenge is to communicate with the console parameters. The console parameters are specified in the kernel command line and will will need to be issued early in order for the setup macro to execute. To show you how the setup macro looks like, here's how the family of the setup macro will appear in initial.h. Here's the example of the family of the setup macro that is defined in a file called initial.h. Now, as we can see, we first define the setup parameters that requires the unique ID, and we need them early. Now, naturally, the static will be constant, and we also need the character setup in order to identify the unique ID that we want. In our case, it'll be council equals and what we're looking for. As we continue down the code, we can see that we will continue to use this unique ID that we've identified earlier in the first part in order to find the sections in the initial setup, in order to find all other codes that are being used as we execute the kernel. The function I showed earlier basically works as the compiler generates an array of characters that are basically string pointers. And these pointers are part of three members, which is the array I mentioned earlier, a pointer for the setup function itself, and a small basic little flag that will help us later on as we build the kernel. The basic key here is the section attribute. The section attribute attaches to the structure, and this attribute instructs the compiler to emit the structure into a special section within the ELF object module. This module is called .init.setup. During the link stage, as all the structures defined in the setup macro are being collected and are put inside this setup file, so when the kernel begins, it will also have all these other functions that the user wants to add within the parameters that was in the first part of the code. Now, some things that we do need to remember about the macro is that the macro is process. It's not compiled like the function. And unlike the function, there's no type checking whatsoever because it's already done for us. However, this does increase the code length. Since it's already done for us, we do have to add it to the code as it's being compiled. Now, user macro does lead to some unforeseen side effects from time to time. This means that when we want to add something in it, it could cause us to have some problems later on that we haven't foreseen yet. Now, this does execute a lot faster compared to functions, but before it can compile, a special compilation macro name is replaced by a macro value. This is also very useful when it comes to smaller codes, unlike a function that is useful with larger codes. Another downside is that macros don't check for compile errors. Unlike functions that do check for compile errors, we need to be careful as we compile a macro. Now, macros also don't generally extend beyond one line, but this is actually very useful when it comes to saving time when executing a files. And that is basically shell functions versus macros. Thank you for your time, and thank you for watching once again. I've had a great deal of experience from Dr. Alex Pons, and I very much enjoyed his teaching and everything that he's had to offer for me in this